Good afternoon, everyone, and welcome to the Herbicide Resistance webinar for 2023. My name is Erica Yaskowicz, and I'm the Crops Extension Specialist with Saskatchewan Agriculture in Kindersley, and will be chairing today's event. The Ministry acknowledges, respects, and has the honor of working on lands in Treaty 4 territory, a treaty that was first negotiated and entered into in 1874 and completed in Fort Qu'Appelle. It is important to recognize that the land on which we are gathered is the traditional and ancestral territory of the Cree, Ojibwa, Saulteaux, Nakota, Dakota, Lakota, and home of the Métis people. We respect and honor the treaties that were made on all territories. We acknowledge the harms and mistakes of the past, and we are committed to move forward in partnership with the Indigenous nations and the spirit of reconciliation and collaboration. CEUs are being offered for CCAs on this webinar. In order to get credit, you need to attend the entire live event, and there will be a QR code at the end of the presentation to collect credit. If you missed the code and have attended live, please email us afterwards and we can work with you to get your credit. I also want to mention that the 2023 Crop Diagnostic School will be in person this year and will be held on July 25th and 26th in Indian Head. More details are coming soon on that event, along with other upcoming field days hosted by local agroarm research sites. Today's presentation will be followed with a live Q&A. The main hub for today will be your webinar screen, and we will share relevant downloadable handouts with you in the chat box area. The entire session will be recorded, so if you miss anything or wish to revisit any of the presentations, you will be able to. Recording links will be sent out later today in a follow-up email. An evaluation will pop up at the end of the webinar this afternoon. Please ensure that you fill out the evaluation, as these help us determine what topics you want to learn more about and helps prioritize research needs for the future. We have a few housekeeping notes to keep in mind during the webinar. If anyone has any questions during the presentations, you may type them in the question box at the bottom right-hand side of your control panel. We will try to get to as many questions as possible, but may need to limit them due to time. Your question will remain anonymous and will only be sent to me. During the presentation, you will be muted so we can ensure there's no feedback that will interfere with the audio. We will start the day off with Clark Brenzil, Provincial Weed Control Specialist with Saskatchewan Agriculture. He has been in the role since 1998 and has a vast knowledge of weed management and crop protection products. He provides information and recommendations on weed control and the Weed Control Act to producers, agronomists, government departments, and agencies, as well as the municipalities. Whenever you're ready, Clark.
Okay, thanks, Erica. Okay, so yeah, this was a bit of an interesting approach to this topic. Okay, talking about well, we've got herbicides, so now what do we do? And so it's a bit of a different spin on what my normal presentation would be regarding herbicide resistance, but a lot of the same themes. So really, in a nutshell, you're not alone. Recent survey of herbicide resistance in Saskatchewan shows that about 72% of the fields that were surveyed show some kind of herbicide resistance, and so that 3 out of 4 fields would have some type of resistance. By and large, I suspect that that'll either be a group 1 or group 2. And really that trend is only moving upward. And so overall, this is going to cost the province about $340 million annually. And you can see on that map on the left-hand side, all the samples that were taken in that survey. So it's a very good representative survey of the entire province. So you're not alone, but there's no way back. There's only moving forward. So resistant weeds will not revert back to susceptible weeds no matter how much you want them to. Essentially, they're resistant for forever. And even in a situation where you may have a weed that is exhibits some type of fitness penalty as a result of having resistance, which only a very small portion of them do. It would take hundreds and hundreds of years for that population to revert back to a susceptible biotype. So I would say consider any weeds that you have now that are resistant are going to stay resistant, and then move forward and try and focus on minimizing the impacts of those weeds moving forward, and also preventing the next herbicide resistant weed from appearing on your land. Only you, the producer, can change the direction of that curve that I showed that was going in a linear path upward. I can't change that line for you. Your herbicide manufacturer can't change that line for you. Your retail person can't change that line for you. It's only decisions that you make on your farm that will impact how resistant weeds develop on your farm. And making changes to prevent resistance, I'm not going to pull any punches. It's going to cost money, but by the same token, coping with herbicide resistance is going to cost more money as well. So it's kind of one of those situations where you can pay money up front and retain your herbicide options that you've got, or exhaust all your herbicide options and end up being stuck in a position where you're spending more money going forward. So when we talk about herbicide resistance, let's kind of clarify exactly what we're looking at and how to distinguish that from tolerance. You hear these words used interchangeably often, but there are differences in the way that they should be used. A herbicide that is tolerant to something has always been tolerant from the first time that that herbicide was introduced. And a herbicide resistant weed used to control that weed, but no longer controls that weed. There are different kinds of herbicide resistance out there. Most of what we have in Saskatchewan is what's called target site resistance. And essentially that's a mutation of a target enzyme within the plant that the herbicide will bind irreversibly to. And the modification of that target site allows the plant to continue to be productive and produce and reproduce normally, while not allowing that herbicide to bind to that target site. We also have non-target site or multi-gene, and so when I talk about target sites, we're talking about a single gene is mutated. With non-target site, usually we're looking at multiple genes that have to undergo a mutation process in order to impart resistance to that weed. And it may be a case of, when the case of group 4s, you're looking at a herbicide that impacts many sites throughout the plant, so that makes that herbicide a little more difficult to develop target site resistance to. It could be amplification of the target site enzyme. An example of that is the way the kochia and the pigweeds amaranth, Palmer amaranth, and water hemp do this by amplifying up the gene that is still susceptible, but it means now that it can bind up more glyphosate, and the plant can still do well. You have altered uptake or translocation through the plant, or you have another system called hypersensitivity, where a larger weed that gets treated by that weed, the leaves die very quickly and drop off the plant, and it prevents that herbicide from moving into the plant in order to be systemic. And so it allows that plant to survive from secondary growth. And then there's another process that particularly glyphosate and glufosinate undergo, which is called vacuole sequestration. And essentially what happens in those cases is that the vacuole is the garbage can of the cell, and so we've got enzyme systems on that membrane between the guts of the cell and that vacuole space. And so those enzymes move from the surface of that vacuole out to the surface of the cell. And essentially it means that things go from the outside of the cell right into the vacuole as it gets translocated into the cell. The other thing that enters into herbicide resistance is that it's a math equation. Essentially, you've got a base rate of mutation that will happen in nature. Um, these resistant plants don't come from somewhere else and land here like an invasive species. They're already in your field, and there's already mutation going on within your field. And so it matters how you manage that field and whether you can reduce the progression of resistance within your field. If you've got that base population there and it just stays at the base population, you're not going to see any impact. So you'll have good control. In this case, let's say you've got one plant in a million as your base population. You'll see excellent control, even if that level increases to some degree. But as soon as your population of plants increases to a greater extent, you may see some plants show up at that lower rate. But then all of a sudden you'll see a weed control failure in that field, and it in some cases it will be inexplicable that you had that failure in that field. But when I talk about mathematics, if we look at a quarter section essentially, and we look at a relatively modest population of 40 plants per square meter in that field, we can expect to find 24 million of weeds of a particular species within that field, which also means that at a 1 in a million mutation rate, you have the potential to have 24 herbicide-resistant mutants within that field. If you're looking at a much higher population, so let's say 400 plants per square meter, that number of potential resistant biotypes jumps by tenfold as well. And so you could have as many as 240 within that particular field. So this is one of the messages that we try and get across in the battle against resistance is to try and make sure you reduce your weed population as much as possible through non-herbicide techniques before you go into the field with the herbicide. And in that way, you reduce your risk of finding that resistant biotype within that particular field. If we look at the different herbicide resistance groups and what their relative base mutation rate is in the field, you'll notice that we talked about 1 in a million plants, and so that's representative of group 1. But group 2 is in the neighborhood of 1 in 100,000, and essentially it's because the way that that target site interacts with that herbicide, it's almost as though you've got a keyhole and you're trying to fit the key within that keyhole, and there's little proteins all along the edge of that keyhole, and your target site is the very bottom of that keyhole. And so when you have mutations on any of these things, as your key goes into that hole, you may not be able to turn that key and lock that herbicide into place. And so that's why group 2 have such a high rate of viable mutations that impart resistance. Other groups outside of that, you're looking about 1 in 10 million, and then you've got the really robust herbicide groups and like group 4 and glyphosate, and even potentially some things like mutations to multiple tank mixes up in that 1 in 100 million level. And this is essentially it's a graphic representation of those numbers that I just showed you. So if you're looking at a 1 billion population, you can go along for quite a while and not really see any changes in the field. Then you may see a little bit as that population starts to ramp up, and then all of a sudden you've got a failure. And that's pretty classical response to herbicide resistance in a field. This thing here is the great resistance spreader, and you can see all that chaff going out the back. And it spreads weeds in two ways. It spreads it laterally out from the combine, so the distance of the cutter bar, it gets blown out very efficiently by some of our chaff spreaders. And then it also gets to move longitudinally as that machine progresses through the field. And so we spread it two ways within that field. If you think you have herbicide, don't wait to get a test. Make sure you confirm that testing or confirm that suspected resistance through testing, and send it to a recognized lab. We have one in Saskatchewan that's the Ministry of Agriculture Crop Protection Lab. It's at 1610 Park Street in Regina, and the telephone number is there for you. And you can look that up on our Saskatchewan.ca website and just search Crop Protection Lab, and you'll come up with that site. What we do at the lab is we do a couple of different types of herbicide resistant testing. We do the grow out and spray system. We don't do this yet, but we're evaluating that for future services being offered. And we also do this type of testing. We used to do a lot of this Petri dish assay type, but we're scaled that back as we go more to our grow out and spray. And so essentially that Petri dish system required a lot of labor in order to get it all set up and get it growing properly. And you'd end up with a situation like this where you've got plants growing in a dish here where you've got nothing on the left-hand side here. You don't have any of the herbicide there, whereas on the right-hand side you have herbicide. And so that treatment 10 would be considered to be resistant where you're getting growth in that treated side. Now we've gone to a growth cabinet system where we're spraying live plants. We would grow them out in a flat and then essentially put the flats into this machine here and spray the flats in order to generate symptoms. And then where we've got symptoms, we've got susceptibility, and where we don't have symptoms and the plants are doing fine, then we've got resistant biotypes. The PCR testing is something that kind of goes over my head as far as what's going on, but essentially what they're doing is that they're looking for these little bands on a gel, electrophoresis gel. And so if they end up with these bands, they have the mutation that you're looking for with respect to herbicide resistance. There are a whole series of these tests that are available now. A lot of that work was done in Quebec, and anywhere we see that M. LaForest name, that's Martin LaForest out of Ag Canada in Quebec. And then we've got C. Geddes, who is Charles Geddes at Ag Canada in Lethbridge. And these are the folks that are developing these genetic tests and PCR tests in order to detect herbicide resistance. So we can see that a lot of these things focus more on Eastern Canadian weeds, but we do have some overlap there. And then we also have more tests being developed as time goes on as well. So keep tuned as to what things could be offered by the lab in the future in this situation. So the use of genetic testing or what type of testing that you use to detect herbicide resistance can vary based on a variety of factors, one of which is time. And so essentially what you can do with genetic testing that you can't do with conventional testing is that you can take a sample here in the middle of the season, test it, and as long as it comes back positive, then you know for sure that you've got that kind of resistance, and you can take management measures to deal with that resistance in the field. But if you come back with a negative, that doesn't necessarily mean that you don't have resistance. It may just be that you don't have that particular mutation that test is looking for. So that's one of the challenges with genetic testing over whole plant bioassay, is that you need to know the mechanism of resistance in that case in order for it to be effective. Yes, it is much quicker, takes 1 to 2 weeks, whereas it'll take 4 to 6 months for the lab test. And the reason it takes so long with a lab test is that we have to, because we're dealing with seed and we're germinating seed, we have to make sure that we're allowing any dormancy within that seed to go away before we can actually start growing out that seed. So if we look at trends for herbicide resistance across the world, essentially since the early 80s, worldwide resistance has been going up in a pretty much linear fashion. Same thing in Canada. We've got pretty much a linear progression of resistance since the mid 70s or early 80s. And we're seeing a similar trend with glyphosate resistance as well. And so we've got of any of the species that I've listed here that have been shown to have developed glyphosate resistance are species that we have here in Western Canada. And so that's a very big red flag that we have to kind of be aware of and make sure that we don't run into problems. The ones with red, those are ones that have developed resistance to glyphosate in Western Canada. So now we have downy brome that's resistant in southern Alberta. The other thing that's going on is that we've got a couple of these pigweeds that are waiting on our southern border to come into the province. And these guys come pre-packed with glyphosate resistance. They're already resistant before they even hit the province. So if we go over some of the results of the testing that was done here in 2019, 2020, the most recent weed survey, and we look at wild oat resistance, and essentially what we're testing for here is just group 1 and group 2. If we look at that testing, we can see that historically the resistance in Saskatchewan has gone up in a pretty much straight line since the early 2000s. There were 70, we'll explain this number a little bit here. This means that there were 77% of fields in the entire survey that had wild oats that were collected for testing. And so essentially, this is 3/4 of the wild oats that were collected. And that if you had a field that didn't have wild oats, then essentially that means that had susceptible wild oats still. And so now we're looking at the percent of all fields is how much resistance relative to all the 400 sites that were investigated. This number here gives the average field area occupied, the amount of land that resistance occupied within the province, and the number the bottom is the number of sort of field acres that would be involved, assuming that we're going to manage on the whole field level rather than on just an individual patch kind of basis. So we can see here that we've got over half of the fields in the province have group 1 resistance of some type. If we look at group 2 resistance, we're looking at about 18% of all fields and 30% of all wild oats that were collected. And if we look at the combination of the two, we're the combined group 1 and group 2 resistance follows the group 2 resistance very closely because the group 1 resistance is so high. This is essentially what's going on here. And again, this has kind of gone flat, both the group 2 and the combined resistance is kind of flattened out a little bit, but I suspect the next survey that we'll see that it'll rebound again and head back up again. So if we look at this on a graphic basis, again, this is kind of the progression of where herbicide resistance is likely to go in the future. If we follow all those hits along the various years prior to this year, and we try and predict what's going on in 24, 25, we could be looking at upwards of 70% of fields with group 1 resistance. We could be looking at somewhere in the neighborhood of 30% of fields with a group 2 resistance, and not far behind about 20% of fields with combined resistance to the both. For group 8 or trialate, essentially, so Avidex, we don't know where that's going because they haven't tested for that for the last 2 surveys, and so we don't know where that's progressing to, and whether it's stable, whether it's going up, or whether it's disappearing. So if you have group 1 and group 2 resistance in the same weeds, you're looking at losing all of this for use in wheat. And then if you're the unlucky one to have 3-way resistance with Avidex, one thing to note here is the cost of all these soil applied products. They're upwards in the $25 to $30 range versus some of our foliar products that are more in that low teens to mid, between $5 and $10 an acre. So your cost of herbicide goes up if you're switching wholesale over to these soil applied products. And if you lose group 8, you really only have one active ingredient left, and that's peroxysulfone for controlling wild oats in spring wheat. Green foxtail, essentially 28%, so a low percentage of all fields, and this is kind of retracted back a little bit just because, again, we've been growing more competitive crops, and more competitive crops means less green foxtail overall. So things have kind of increased a little bit on the green foxtail scale. Red root pigweed has increased quite dramatically over the last survey. Cleavers has also increased fairly dramatically over the last survey, but again, a very small percentage of fields overall. Shepherd's purse, it's the second survey that we found it in the 2020 survey, and now it makes up over 40% of the samples that are being collected. Wild mustard, again, 50% of the fields being tested, a fairly small percentage overall fields. Pale smartweed, first time it's appeared on the survey in Saskatchewan, and it's already up to pretty much half of samples that have been collected in the survey overall. Stinkweed, again, it's just kind of flat from the previous survey, and again, a fairly small percentage of fields. Chickweed, progression from 2010, it seems pretty steady upwards, and almost half of fields tested have group 2 resistant chickweed. Hemp nettle, same thing from 2010. It's been a pretty linear increase overall in Saskatchewan, to the point where we have 60% now. With lamb's quarters, first time it's appeared on the survey, and only one field showed up in that case. Glyphosate resistance in kochia, there was a survey done specifically in kochia in 2019, and looking at things like glyphosate resistance, group 4 resistance. And so essentially what they found is that 87% of kochia samples that were collected were found to be resistant to glyphosate. So that's essentially means that things are progressing very quickly. The first time that we found glyphosate resistance in kochia was back in the 2010-2011 timeframe. The degree of shading within these dots, if you've got a really dark dot here, it means that you've got a pretty stable population with glyphosate resistance. if you've got one of the paler dots, it means that that population, there's resistant biotypes mixed in with susceptible biotypes. And so essentially that means that that population is still trying to figure out what it wants to do as far as glyphosate resistance. And so you might be able to take that field and influence it back to a more susceptible state. Also in this survey, we found that about 45% of surveyed kochia populations have a very low level of dicamba resistance. And so that's something to kind of keep aware of. Also, there was a survey done in the following year in Alberta, and it showed that there was also fluroxypyr resistant being found in kochia in the Alberta survey. And generally, when you can find it in a survey, it means that it's pretty widespread. The one thing that's kind of interesting about fluroxypyr resistance and dicamba resistance is it appears that there's not a whole lot of cross resistance between the two. So you may have populations of dicamba resistance being controlled by fluroxypyr and vice versa. This is the downy brome in southern Alberta that survived about, let's see, we're probably looking about a 5 or 6 or 7 times of the glyphosate rate. So this rate out here is pretty much the maximum rate that you would apply in the field. And those are the field rates. And then we've also just recently found a group 14 resistant kochia as well. And so this is the normal field rate for heat. And so the kochia that is in this sample is about 16 times resistant, which would suggest that we're probably looking at a population that has target site resistance or a single gene mutation to create this population. So we're headed towards a wall. You as a producer need to decide whether you're going to pump the brakes, whether you're going to swerve, or whether you're going to just continue going head on forward and hit the wall. And so when we talk to producers about what their management strategies are for herbicide resistant weeds, you can see they talk about group rotation, they talk about tank mixing herbicides, they talk about pre-herbicides, and then they also talk about crop rotation. But most of the time that means that so that I can use a different herbicide is essentially what it means. So the real key management strategies that producers are using to manage herbicide resistance is more herbicides. And essentially the solution to this problem is not going to come out of a jug. You're going to have to change the fundamental way that you farm in order to make this problem stabilize or kind of hit a point where it can be managed effectively. So you don't want to get caught on the herbicide treadmill, because they've found that if they get caught on the herbicide treadmill down in the US, essentially they end up in a big hole where they have no options to get out of. And so we want to make sure that we don't get caught in that hole up here as well. So the harsh reality is that we've got a finite number of pathways in a plant that herbicides will work on, and the chemical manufacturers are not holding out on you. Here's an example taken from the USDA, looking at how much is being spent on discovery for herbicides versus how many groups or new herbicides we're getting out of that process. And so essentially that blue line there is how many new modes of action we're finding as a result of that testing. There was one little discovery out here just recently in the last couple of years, just about 2018, 2019. But unfortunately, that's for use in rice. So there's not a whole lot of people growing rice here in Saskatchewan. So that one doesn't do us a whole lot of good. But maybe at some point we'll see derivatives of that that herbicide that was discovered be produced and be available for things like wheat or corn or canola or in the bean family, in the pulse family. So using that other group one, I'm talking about clethodim or prinoxidin in this case, is not a viable rotation because eventually you'll select resistance to those as well. And essentially switching to group two in that situation is kind of like going from the frying pan into the fire with respect to long-term management of wild oats and resistant wild oats. We do have three-way resistant kochia now as well, so that's well established in Western Canada. Group 2 herbicides will no longer control kochia. Cleavers, wild oat, wild mustard aren't far behind. Once a weed's resistance, there's no going back, and we talked about that earlier. So we essentially have to move on from the hope that we're ever going to push that resistance level backwards. And again, a low level of resistance in your field is not a management concern, but you have to be aware of that and actually manage to maintain it at that low level. So some strategies to manage weeds without herbicides. Rotation is a good one, and not just so that you can use other herbicides. What you want is you want a mixture of competitive and uncompetitive crops. You want a mixture of broadleaf and grass crops is essentially what you want in that mix. And so the general consensus is that we're looking at 4 years or more in that rotation. As it said, we're looking at a mix of competitive and non-competitive crops, including legumes and broadleaves and grasses. And then every once in a while, you should throw a forage crop in there for about 3 years in order to bring the number of weeds in the seed bank down. And that can include cover crops where they're appropriate. So if we integrate forages into a field, we can see how they impact the weed seed bank in that field. And again, these are typically things that are being cut for hay. And so essentially you're taking the weed seeds off the field with the hay before they're mature. And then you're not getting replenishment of that seed bank as time goes on either. And even with things like Canada thistle, you can draw down the viability of the roots in those fields even by using a forage as well. Wild mustard is a little bit different because it's got a very long seed bank life, and so that's why the reduction of that seed bank was fairly minimal. The one thing you do get in those cases where you put forage into a situation is that you get dandelions. And so that's something I think that we can deal with. But the other ones are the ones that are more concerned for management overall. For things like kochia and Russian thistle, they have a very, very short seed bank in the soil. Generally, we're looking at 2 to 3 years, and you've got essentially just remnants of that population within that field. Wild oat doesn't last in the field as long as everyone thinks. You get when you ask that question, everybody says, "Oh, it lasts for like 20 years or something like that." Well, if we look at some of the research that has been done and look at where you find those wild oat plants, essentially, if you leave them on the soil, they've got a very short seed life in the soil, and the population drops off very quickly. It's only when you bury those seeds that they persist for a little bit longer, and you have higher seed banks right off the bat. But eventually, they will also decline down to near zero at year 7. Generally, on heavier soils like clays and things like that, you have a longer life in the soil than you do on loams or lighter soils. cropping practices have a big influence on your weed populations, and the goal here is just to improve the competitiveness of the crop so that you reduce the population of the weed that you have to deal with. And so if we look at a normal seeding rate for barley that's in this range here, and we push that up into the doubled area, you can see where your yield potential for that crop goes up, and your seed potential for the weed goes down as you put more crop plants into that system. And you can see here there's a picture from the old days when we were looking at West Star canola and the old soil applied herbicides. Essentially, the only difference between the plot on the left and the plot on the right here is plant population of canola. And this is the 1 to 2 pound rate, and this would be the 5 pound rate that was kind of recommended at those in those days. Even a relatively uncompetitive crop like lentils, you can get a competitive effect by increasing the seeding rates. And so we can see here that our grain yield potential for lentils went up here, along with the biomass of the crop, and the biomass of the weeds dropped as a result of increasing the seeding rates. We did a test with IHARF, which is the AgriArm site out of Indian Head, and we were asking the question, well, how does row spacing combine with seeding rate to impact competitiveness against weeds? And so they have this neat seeder that they can just kind of pull some pins and crank some cables and move the seed rows in and out. And so we utilized that. We also did some confirmation work at other AgriArm sites across the province. And essentially we achieved a wider row spacing versus what they had on hand by blocking every other row in essence. So when we're looking at the results from that, this is kind of a good visual indication of what we're looking at. So on the right-hand picture, all the yellow over here is mustard that was cross-seeded as a model weed. And you can see in this picture here where you've got a 2 times seeding rate and a 12-inch row spacing, you've got no mustard in there. So essentially there's no herbicide in here to control the mustard. And I believe we put oats in here as well for a duplicate for wild oat. But when you go at a lighter seeding rate and a wider row spacing, you're leaving yourself susceptible for weeds to persist in the plant stand. So we looked at some statistics, and essentially the way that we can gauge all these statistics that we'll see here is that if this number here is below 0.05, that essentially means that there was significant differences within these points along here. If you had something below 0.5 in this situation, like we do, essentially it means that there was a linear trend that was significant. Or if we had a 0.05 number in here or lower, it means that there would be a significant curvature type of idea. And so in this case, we found that early season weed biomass, there was a trend towards improvement in those cases when we had both wider rows and higher seeding, or wider rows for sure, but not so much with seeding rates. We look at 1 to 9 visual rating. Essentially, there was significance in these points along here, and there was a linear trend along there. So that meant that row spacing had an impact, as well as seeding rate over here had a quadratic or curvature type response. Seed head density, this is a bit of an interesting thing to try and read here, in that essentially really what you want to look at is that with this 41 centimeter row spacing or 16-inch row spacing versus the 10-inch row spacing down here, is that when you increase the seeding rate with the 10-inch row spacing, you continue to get a response well into the higher seeding rates. Whereas with this closer or with the further or wider row spacing, you tend not to get a response to your increase in seeding rate. And that's essentially what we're looking at with that chart. Crop maturity improved essentially when we had narrower rows. So we had shorter maturity when we had narrower rows, and we had shorter maturity when we had higher seeding rates. We had the ability to compete is just essentially a reverse of the dockage in the sample. And so essentially with wider rows, we had a better ability to compete. And with higher seeding rates, we had a better ability to compete as well. For crop yield, narrow rows, better ability to, or better crop yield overall. But then with seeding rate, it was pretty flat and there was no significant difference between the seeding rates. Again, unless you've got this row width response going on here as well. Test weight improvement with row spacing, and also a trend to improvement with the seeding rate as well. So our goal is to improve competitiveness. One way we can do that is make sure that we minimize our disturbance as much as possible and maintain our fertility as close to the seed row as possible. Post seeding or early emergence tillage is probably a good option to look at as well. And with these rotary hoes, essentially what they're designed to do is just flick small weed seedlings out of the ground when they're in the white thread stage. And essentially, if you look at the video there, that's kind of what the stage that we're looking at for those weeds to get flicked out of the ground. When we have larger crops in that situation, they resist getting flicked out of the ground, and so you end up with weed control that way. The interesting thing, well, I guess the fun thing about these is that you end up going in road gear across your field, and so they're best operated as fast as absolutely possible. You can get these things in space in sizes up to 60 feet for a 3-point hitch model, or up to 66 feet for a tow behind version. So they will cover a lot of ground in a fairly short order. Harvest weed seed management is another option for managing herbicide resistance. Remember, we looked at this guy here early on in the presentation, and so we're looking at the great weed spreader. Well, one of the ways that we can use that to our advantage is to collect the chaff that's coming out of the back of the combine. And in this case here, we're looking at collecting it and putting it behind the wheel tracks. And when you have that kind of situation, you have to essentially do controlled traffic farming where every single implement goes across that wheel track. And you try and disturb that track as little as absolutely possible. So essentially, you're doing controlled traffic farming. You're running your sprayer on the same tracks. You're running your seeder on the same track. And what they have found in Australia is that if they use this system, they can reduce the weed seed bank in between those tracks so much that they don't have to spray in between those tracks anymore. They just end up spraying the tracks. And if you get lots of materials in there, in Australia, they tend to just put a match to it and burn it. But you can also utilize composting in that area. And so essentially you put more and more material on there, it suffocates the weeds in there, and you end up getting control of the weeds. What may work better here in Saskatchewan is a cage mill option for managing weeds off the back of the combine. And so essentially this little picture on the right here is a good example of what's going on. Well, we'll look at over on the left here first. So essentially what happens is that you get a little plenum in here that's put in the back of the combine that redirects the chaff downward rather than up into the straw chopper to be flung all over the place. So you try and steer all that stuff down into the whatever's managing your weed seeds. And so as you get chaff kind of going into these things, you on the top you've got a stator that stays in one position and has bars on it, and then on the bottom you also have like a rotor that ends up spinning at about 3,000 RPM. Um, in between those stator bars, and so it ends up that it flings all this material out, and it has to impact the bars on the way out in order to get out of the mill. There's several integrated versions of this now. Originally, there was one called the Harrington Seed Destructor. Their first version for integration was a horizontal mill, and essentially what they did is they drove it via hydraulics, and so that meant that you had to have a whole separate hydraulic system in order to drive it, versus their direct competitor, which is a seed terminator. And that one there was belt driven off of the idler on the back for the straw chopper. But eventually what happened is that the Harrington Seed Destructor decided to change their design, and they mounted their mills vertically now. And then they had augers in the middle here between the rotors, or between the mills, that would draw that material into the cage mills, and then it was driven off of belt as well. What's inside these things is a little bit different. In the Harrington Seed Destructor, essentially you've got bars on both stator and rotor, and then you've got a fan here in the middle that pushes things outward to get them into all the stator and rotor bars so that they make impact with those. With the Seed Terminator, they did things a little bit differently. They decided to put like a heavy screen in here, and the rationale behind that was that it would maintain the material in these screens for long enough that it beat it down to a fine enough powder that it would progress out through those screens. They had problems with wear with this thing, so they beefed up their stators a little bit. And so now they've got bigger openings and a little bit stiffer material there as well. We do have a Canadian entry into this whole concept, which is the Redcop Seed Control Unit, and that's built just northwest of Saskatoon. And there's also another competitor out of Australia called Tech Farm Weed Hog, which has a little bit of a unique design. If we look on the inside of the Redcop Seed Control Unit, we've essentially got these channels here with that have carbide on the outside of them in order to wear, or tungsten, in order to wear properly. And their big selling point is that you can reverse both the stators and the rotors in this in order to wear on both sides. So you double the wear potential of your machine. But basically it's very similar to the old Harrington weed destruct or old Harrington Seed Destructor and the Seed Terminator. This Tech Farm Weed Hog has a little bit different design, and the whole goal here is that it was intended to try and improve the use of power within the combine. And the idea is that they're using less power, and it would be less costly to operate than the other three. Essentially, what the cost for the first three are about $75,000 US, and they pull about 50 horsepower off of the motor. So you have to have a class 7 or above combine in order to drive these things appropriately. But if you do the math, the economics on these things, you're looking at, if you amortize the purchase of these things, and you look at all the fuel use and all the wear parts and maintenance and things like that, you're looking in the neighborhood of $7 to $10 an acre, which is still going to be cheaper than those soil applied herbicides essentially. This one over here, it's more 50,000 US, and you're maybe looking at 30 horsepower being drawn off the combine. And so the idea is it will fit on older combines and smaller combines. But the difference is you get about 95 to 98% control off of the first three. And this one here, you get about 80% control. And so this is the weed terminator working in the field. There's a fellow named Josh Lade that um, has 4 combines with these things fitted on them up in the Osler area. And he led us into his field to have a look at these things and see what was going on with them. So um, they create a lot of dust. They sound like a jet engine when they fire up, and so they're quite interesting to kind of take in and see how they operate. So at the end of the day, this is kind of what you have, is that if you've got this kind of chaff going in with a whole bunch of volunteer canola, and you put this in a tray to germinate it, you get lots of volunteer canola plants. This is what it looks like after it's gone through the Harrington seed destructor, and then you get very few viable plants coming out of that at the other end. Another option for management of resistant weeds is herbicide layering. And essentially what it means is that it's kind of an extension of tank mixing. And it's the use of multiple active ingredients and herbicide groups to control the same weed in the same field. And in the case of layering, it means that it doesn't necessarily have to be in the tank with the foliar herbicide. You can also use soil active herbicides, and essentially they do one of two things. They'll either draw down the weed population so that the foliar herbicide has less pressure, and essentially if you've got any escapes from the soil active herbicide, then you've got that foliar one to come along and clean up after the soil active product. You can get some benefits out of layering, even on its own right, let alone for the resistance. And so again, this is kind of a demonstration of what your mutation rate is for the various herbicides in the field. This is some work that was done by the U of S here a few years back on canola, and the same thing applies for glyphosate, Liberty Link canola, or Clearfield canola. It doesn't seem to matter which one it is, it all kind of responds the same. So essentially, if you put glyphosate alone in here, you get a certain percentage control and reduction in biomass versus the untreated. Same thing with just applying quinclorac in crop. The clomazone, which is a soil active product, really doesn't do all that well just on its own. But when you add it in with either the quinclorac or you add it in with the glyphosate, you end up getting multiple benefits from applying all those herbicides together. So this is biomass, and this is cleavers contamination in the seed, and this is something that your miller is going to appreciate. But this is something that you're going to appreciate, is that essentially these letters mean that if you've got treatments with the same letter, they're not significantly different. So in this case here, this is significantly higher than this. These two are roughly the same, or these three are roughly the same, and much more than the glyphosate on its own and the quinclorac on its own. Timing of weed control has a big impact on your potential yield, and soil active products can provide that as well. This is some data that comes from the old Avidex yield challenge days, and so essentially it kind of gives you an idea of what the potential for the yield of wheat is when using that when removing the weeds at a particular leaf stage. And then this just puts numbers to that. So you can, going from um, emergence to the 2 to 3 leaf stage for a foliar treatment, you can lose $24 an acre. So they can contribute without actually having to deal with resistant weeds. The key to success is getting ahead of a weed problem. Don't wait. You want to deal with those resistant weeds. In Europe, they are doing herbicide layering in Europe, and essentially they're using about 6 active ingredients, and it's costing them about $120 an acre in order to control this weed called blackgrass. And that's just because they waited for the problem to show up before they started responding, and so they ended up with this situation where now they're stuck actually applying all this herbicide. Some challenges to integrated weed management, which is essentially what we've been talking about, is that nitrification inhibitors have encouraged folks to start flinging fertilizer all over the soil surface again. And aside from any potential nitrogen losses, if you're not positioning that material next to the seed row, you're feeding weeds is essentially what the story is. And so this is a good indication of what you're looking at for weed biomass based on where you place your herbicide. And there's been pretty heavy promotion of high-speed tillage, and the wet conditions kind of drove that a little bit, but hopefully we can maintain our direct seeding and make sure we've got weeds under control. Commodity prices are not all equal. If they were, then agronomy would dictate everything, and the dollar wouldn't. But that's the reality that we're living in. So you've got a few particular crops that make all the money, and so that's driving short rotations and driving resistance that way. And also we've got commodity organizations that are fighting amongst themselves for acreage of their particular crop. If you're looking at integrated weed management to try and manage herbicide resistance, you should be looking at short and long-term goals. Key to minimizing the risk of resistance is to reduce those weed densities before you get in the field with the sprayer. And there are some cultural methods that are just as good or better than the herbicides at reducing weed populations, since it may take some time, but generally you can get to that end goal if you go there. And so that pretty much is what I had to say today. And I don't know if we have time for questions or not.
Well, thank you, Clark. That was for a great presentation. As a reminder, if you have any questions today, please enter them into the chat box on the bottom of your control panel. So the first question is, are we able to send away soil samples for herbicide carryover or any tests that can be done accurately to show that herbicide carryover is an issue with complete certainty?
No.
All right.
It was short and sweet, but yeah, no.
Well, our second question then, will there be a large price difference between genetic herbicide resistance testing compared to the lab where the plants are grown out?
I suspect that the price of the genetic tests will be higher than um, the spray out type of tests. And in part that's because of the cost of the materials that have to get used in those situations, and to some degree, the demand for that service as well.
Excellent. Thank you, Clark. In regards to using chaff decks and dropping it directly into the wheel tracks, could that not also cause more weed spread versus dropping it in the center of the tracks?
Um, the idea behind dropping it right behind the wheels rather than in between the wheels is that you get that pounding over and over again on those wheel tracks. And that's what that's doing, is that's um, creating an environment there where you get more rot, you get more decay of seeds taking place in that area versus that one in the middle. And then the challenge with the one in the middle is that, okay, now you've got a row there, what do you do with it? If you're pounding it down with wheels all the time, you don't have to worry about it as much as if you've got that one in the center.
Wonderful. Thank you, Clark. Um, is there any talk about making harvest weed seed management tools mandatory on combines? Would the government ever make a mandate to require equipment companies to put these on their equipment?
That's highly unlikely that will occur, but I suspect that the marketplace is probably going to go there anyway. If you were to go and look at, say, a Kloss combine or a New Holland combine and look in the back end of that, the shell for those machines is in there already, and all you got to do is add in the moving parts, and you got yourself a weed destructor of some kind. The other thing that is kind of a development is that the Redicop seed control unit, their sales model is not a bolt-on aftermarket sales market, but more direct from dealer sales, and so they're doing it as a dealer add-on at the dealership versus one that you essentially get shipped from Australia and you end up bolting it on yourself.
Wonderful. Thank you, Clark. What are your thoughts on stacked canola products for weed control and resistance management?
One of the things that could be a concern there is, remember when I talked about the vacuole sequestration um, potential pathway for developing resistance. They think maybe that is linked to the phosphorus management system within the plant. And both glufosinate and glyphosate are both phosphorus-based herbicides. And they think that that might be driving some of that rapid movement from the outer membrane into the vacuole right away. So if you've got one that's linked to that phosphorus pathway, then it could be that you end up with resistance to both at the same time.
Thank you. Where was the group 14 resistant kochia found?
It's in the Rosetown area.
Thank you, Clark.
That's as good as I can do.
Can we remove weed resistance with hay or forage crop production? And if so, how many crop years to help manage resistant weeds like wild oats and kochia?
You can draw down the weed seed bank and make resistant weeds more manageable. I don't think once you've got a weed population that has resistance in it and where you've essentially gone from that, let's say 1 in a million or whatever that base level of mutation is, and it's scaled up now to it's across the whole field. I don't think you're going to turn that clock back. Those wild oats in that field are going to be resistant to that herbicide, regardless of whether you hay it or not. Essentially what you're doing is you're drawing the weed seed bank in that soil down to the point where now the level of wild oats in there is tolerable for a few crops.
Wonderful. Thank you, Clark. So thank you again, Clark, for all of your great information. We appreciate the time you took to join us here today. At this time, we would like to thank everybody for taking the time to join us here for the event. Don't forget to use the QR code on the screen to get credit for the event if you are CCA. If any issues or have missed out on the code but attended live, please contact us and we will make sure you get credit. Credits are only available to those watching the entire webinar live. Please take the time to fill out the survey that will pop up when you exit from the program. If anybody has any questions regarding these topics or anything else related to farming, please contact your local Sask Ag Regional Office or the Agriculture Knowledge Center at 1-866-457-2377, and we will be sure to put you in contact with a specialist to help answer your questions. Thanks again for joining us in today's session.